Good afternoon, everyone. So, welcome to my YouTube channel, Maths Satram. So, today we are going to see second practice set on functions of bounded variation. These are most important questions. Okay. So, till now, if you have not subscribed my YouTube channel, subscribe it immediately for such type of interesting questions. So, let's start today's session now. Okay. So, first question is f and g are functions of bounded variation such that variation of f is nothing but fb minus fa and variation of g is nothing but fa minus fb. Then option number 1 is f is monotonically decreasing and g is monotonically increasing. Second one is f is monotonically increasing and g is monotonically decreasing. Third one is f and g are monotonically increasing and fourth one is f and g are monotonically decreasing. Okay, so let's see it. We know that if a function of bounded variation is monotonically increasing, then its variation is fb minus fp. And if it is monotonically decreasing, the variation is nothing but fa minus fp. So we hopefully guess that f should be monotonically increasing and this g should be monotonically decreasing. Option number B should be correct, but it requires proof. Okay. Okay, so let's do it. Solution. So, so let it is given f monotonically v function of bounded variation variation with vf is equal to fv minus fa. Okay. So let x1 x2 such that okay, then what is for xi I1 to 2 we have what we have fb minus fa. We can write it by fb minus fxi plus fxi minus fa. This I can write fb minus fi plus fxi minus fa. But axi and b, these are partitions. So this will be less than variation. So this is less than variation. This is less than equal to variation of fab. But this is given nothing but fb minus fa. So what we have actually, this implies fb minus fa is less than equal to fb minus fxi plus fxi minus fa. Okay, but xi a is here and b is here. Xi's are here for I goes to 1 to 2. So what does it mean? The distance is this distance of this one. By this, what we conclude? By this, what we conclude? This implies fx fb minus fxi plus fxi minus fa is nothing but fb minus fa. So xi is somewhere. The distance between x to a plus distance from xi to b. Their sum is fb minus fa. What does it mean? What does it mean? It means that this implies fa is less than fxi less than fb. Why we have? Because bf is fb minus fa and variation is always non-negative. So this implies fb is greater than fa. Okay, but this should lie in between. So that is why this will happen. fxi will be lie somewhere. Okay. Okay. For I is equal to 1 to 2. Okay. Now I can fb minus again fb minus fa. I can write it again by adding and subtracting fb minus fx2 plus fx2 minus fxi, sorry, fx1 plus fx1 minus fa. Again, using triangle iniquity, I can write fb minus fx2 plus fx2 minus fx1 plus fx1 minus fa. Okay, but we know that fxi, you can take fx1 is lie between fa1 and fb. Similarly, if I put I is equal to fx2 lies between fa and fb. So it means this quantity is non-negative. So I can write it okay. This quantity is non-negative and this quantity is also non-negative because fx1 is greater than fx. But nevertheless, first you observe that this is less than bfab, but this is less than, but this is nothing but fb minus fa. So this implies, but these are non-negative quantity. So I can write finally what I will got, fb minus fa is less than fb minus fx2 plus fx2 minus fx1 plus fx1 minus fa, that is less than equal to fb minus fa. Okay, but this is equal. But this lower bound is this, upper bound is this. What does it mean? fb minus fx2 plus fx2 minus fx1 plus fx1 minus fa is equal to fb minus fa. Okay. So now solve it. So fb and fa will be cancel out. So this is cancel out and this is cancel out. So this implies, after solving it, fx2 minus fx1 is fx2 minus fx1. that is greater because this is absolute value. So this implies fx2 greater than fx1. This implies f is monotonically increasing. Okay. Similarly, we can show G is monotonically decreasing. Okay. So this is done. Similarly, we can show that we have proved that f is monotonically increasing. Similarly, we can show that G is monotonically decreasing. So which option is correct? Option number B is correct. So, let f be a function of bounded variation. Then f is unbounded. Option number A cannot be correct. Every function of bounded variation is bounded. Second one is absolute f is not function of bounded variation. Option number C is third is absolute value of f is function of bounded variation. D is none of the above. Let's check it. Okay. We know this inequality. We know absolute of x minus absolute of y is always less than x minus y. Okay. Let P, if P is a partition, then what will happen? We will have, then this implies f x n minus f x n minus 1 is less than f x. Sorry, I should take I in place of n. I minus 1. fxi minus fxi minus 1. Because I am taking my x fxi and y fxi minus 1. So from this I can write like that. So I goes to 1 to up to n. Okay. So this implies SP mod f, that is nothing but summation I goes to 1 to n, that is less than that is equal to SPF. But SPF is always less than this is less than BF, that is finite, since F is function of bounded variation. Okay. So this implies supremum P belongs to row AB. SP is less than. Okay. So this implies This implies supremum P belongs to row AB, which means collection of partition. SP exists in R. So this implies F is function of bounded variation. Okay. Now from 1, we have supremum what is this? Because F is function of bounded variation. This implies variation of absolute F is less than B. Okay. So mod F is function of bounded variation and variation of mod F is less than equal to variation of F. So which option is correct? Option number C is correct. Okay. Option number C is correct. If F be a continuous function and mod F is a function of bounded variation, then option number F is unbounded. Every continuous function is closed and bounded interval is bounded. So option number A cannot be answered. Option F is not function of bounded variation. C is F is function of bounded variation. D is none of the above. Let's check it. Okay. Let P is equal to AX0, X1, X2, Xn minus 1. Xn is equal to B. B a partition of AB. Okay. So what is this? Fxi Fxi this will be equal to Fxi minus Fxi minus 1 if Fxi and Fxi minus 1 have same sign or at least one is 0. If Fxy and Fxi minus y are positive or they both are negative or any one of them is 0, then this inequality hold. Okay. Okay. If Fxi and Fxi minus 1 have negative sign, then what will happen? Then there exists eta I such that eta is in between this and f will be 0 at eta by continuity of f. Because we know that if f is a continuous function and they have suppose fxy is positive and fxy is negative, so somewhere it will cross fxi is this, fxi minus 1 is this. So this is negative, this is positive. Somewhere at eta, this will be 0. At this, f eta I is 0. Okay. Then what will happen? Then what will happen actually? fxi minus fxi minus 1. I can write fxi minus f eta I plus f eta I minus fxi minus 1. Okay. Now use triangle inequality here. So use triangle inequality here. Now f eta I is 0. I told that if at least 1 is 0, then this is equal to mod thing. Because f eta I is 0 by equation 2. By equation 2. Let's say it equation number 2. If at least 1 is 0, then I can write like that. So here f eta I is 0, then I can write like that. So this is equal to f xi xi minus 1. Okay, I can write like that. xi minus 1. Okay, so let's say from equation 3. From equation 2. Because f eta I is 0. At least 1 should be 0. But eta I is 0. That is why I can write like that. Okay. This is equal to this. This is equal to this. Okay. Okay. So what we have actually? So this implies f xi minus f xi minus 1 is less than f xi minus f eta I. This is eta. Eta I f eta I minus f xi minus 1. Okay, that's the equation number. So from 2 and 3, we conclude that given any partition, because we are getting additional points, eta I. So we can say given any partition P, we have another partition P dash such that P containing P dash, okay, and SPF is less than SP dash, okay, like this. But this is because you see that we can add eta I here in between xi and xi minus 1. So we are finding a finite partition in which it has number of points, more number of points. So obviously, and this is less than absolute thing. So this implies SPF is less than SP star of absolute F. But this is mod F is function of bounded variation. This will be less than this. So this implies SPF. Now take supremum. But this is finite. It means this exists. It means supremum P belongs to row AB, SPF exists in R. So this implies F is function of bounded variation. Okay, from here, what we can conclude here, this implies SP, this implies from here, this implies from here, I can conclude, from here I can conclude, from here I can conclude that variation of F is less than variation of mod F. But we know that variation of mod F will be always less than mod F. So from this and this, what we will conclude from this, variation of F is variation of mod F in this case. Okay. If F is continuous, mod F is function of bounded variation, then F is also function of bounded variation. In this case, variation of F and mod F will be equal. Okay. This is not given, but I have done additional thing. So it is, we have to choose option. So F is function of bounded variation. So option number C is correct. Okay. Option number C is correct. Now move to next question, fourth question. Let F and G be function of bounded variation. Then max of Fg is function of bounded variation. Minimum of Fg is function of bounded variation. Both A and B. D option is neither A or nor B. So solution. So you see that max of Fg, how it is defined? It is defined F plus G plus F minus G upon 2. Okay. And how minimum is defined? F, okay, plus G minus F minus by 2. Okay. Okay. Now, F close interval G, A, B to R. are functions of bounded variation. So this implies f plus g and f minus g are functions of bounded variation. If f is function of bounded variation, its absolute function is also function of bounded variation. So this implies f minus g, okay, is also, and will keep f plus g as it is, are also functions of bounded variation. Now I can take sum of base 2 and difference of base 2. They will be also function of bounded variation. This implies f plus g plus f minus g and f plus g minus f minus g are also functions of bounded variation. If I will take scalar multiple, real scalar multiple of function of bounded variation, they are also function of bounded variation. Okay. So this implies f plus g plus f minus g upon 2 and f plus g minus f minus g are also functions of bounded variation. But they are nothing but, what is this? This is minimum, maximum, and this is minimum. Okay. So this is equal to max of fg, and this is equal to minimum of fg, are functions of bounded variation. So if fn and g are functions of bounded variation, f maximum of fg and minimum of fg are also functions of bounded variation. So option number A is correct, B is also correct. So both A and B are correct. So option number C is correct. Option number D is not correct. Okay. Okay. Now move to last question of this session. If you have theta in between 0 and pi by 2, then fx is equal to f upon sin x if x belongs to open 0, theta, close, and 1 if x is equal to 0. Okay. So option number 1 is given that f is monotonically increasing, f is function of bounded variation, 1 upon f is function of bounded variation. All options are correct. Okay. So let's see it. Solution. So fx is equal to, given that x upon sin x if x belongs to, okay, pi by, sorry, theta. Theta. And 1 if x is 0. Now first we will check this is monotonically increasing or not. So what is derivative? So what is this? So f is, if I am taking x belongs to 0 theta, then what is the derivative? F dash x is equal to sin x का square, so 1 sin x minus x into cos x. Okay. What is this? This is sin x minus x cos x sin x का square. Okay. So I can take cos x outside. This is tan x minus x. Okay. So now you see that, note if I am taking gx is equal to tan x minus x, then what is the derivative of this? This is sec x square x minus 1. But this is always for all x belongs to theta 0 to phi. Okay. It means tan x minus x is increasing, monotonically increasing. Monotonically increasing. Okay. But so it will be at initial point. If it is monotonically increasing, then you tend extending to 0. At extending to 0, limit extending to 0, tan x minus f, what it will be? 0. Tan x minus x. This is what is the limit? 0 minus 0. It means tan x minus x is non-negative. So if this is non-negative, so and cos x non-negative, sin x is non-negative, it means this is this. So derivative of f dash is for all x belongs to open 0. Okay. So this implies f is decreasing on 0 to theta close. But f is continuous. We have fx fx. Okay. Fx is greater than limit x tends to 0 plus fx. Okay. Because f is continuous. What is this? This is 1. So this implies f is increasing monotonically, increasing monotonically, increasing and fx greater than 4 all x belongs to monotonically increasing on on 0 to theta and fx is greater than 4 all x belongs to 0 to theta. Okay, but since f is monotonically increasing functions are, so this implies f is function of bounded variation. Okay, now fx is greater than 1 and this is greater than 0. 1 is greater than 4 all x belongs to 0 to pi, 0 to theta. Okay, so this implies 1 upon f is also function of bounded variation. So this implies 0 to theta. This implies 1 upon f is also function of bounded variation. So f is monotonically increasing. So we have concluded that f is function of bounded variation. But fx is greater than equal to 1 for all x belongs to 0, theta close interval and 1 is greater than 0. It means it is k is equal to 1. So 1 upon f is also function of bounded variation. Okay. So we have three conclusions. F is monotonically increasing, f is function of bounded variation and 1 upon f is also function of bounded variation. So one option is correct. First option is correct. Second option is correct. Third option is also correct. This is B. Okay. This is C. And this is D. So option number 1 is correct. A correct. B is correct. C is correct. So it means all options are correct. A, B, C. So all options are correct. Option number D is correct. Okay. So today's session up to this. If you have any problem, you can comment on my YouTube channel. Like, share, subscribe and comment on my YouTube channel. Thank you very much for today's session. Thank you very much. We will see you in next session. Thank you very much.